Here with example 10, what I quickly did is just rewrote what's information in the book so that way we can talk about it just a little bit, ever so much. Basically what's happening is that you are sitting on the river of the bank, and every 5 minutes you're measuring the velocity flow. So this is what it's saying. Is from starting out, the flow was 1 meters per second. 5 minutes later, it was 1.2. 10 minutes, a total 10 minutes in, it was 1.7. Okay, and you want to know how far upstream did the bottle travel during that hour. We want to estimate the distance. We're going to estimate it twice, once using the left endpoints and once estimating the right endpoints. Okay, it tells you there's 12 equal intervals. Okay, an interval then would be going from 0 to 5, that's one interval, but that's 5 minutes. 5 to 10, 10 to 15, 15 to 20, you're kind of getting the idea. Okay, so to estimate the distance, remember each of these intervals are of length 5, right? So to estimate the distance, how we're going to do it is we want to measure one, since we're going to do the left endpoints, just think about it as like almost like a graph. It's where we have maybe a curve in here. We're not sure what the shape is. Let's say just something like that, okay? And what this is the velocity. So what all of this over here are, obviously these are like our x values, and over here are our y values. Or this is the length of our base, and the y values would be the height, okay? And so when we go to get those triangles, or not, I keep saying triangles, don't I? Whenever we go to get those rectangles, what we're going to do is once do the kind of like the lower sum or the left endpoints, and the other time it's going to be the right endpoints or like the upper sum. Okay, but it's going to be a lot easier than what we did before on just the last examples. Okay, so the distance, no matter what the bases are, the bases of each of these rectangles are always going to be 5. Okay, so what I'm going to do is we're going to just multiply all once by 5 instead of going each piece by 5. Obviously, it's a common factor. Okay, so obviously to get from 0 to 5 minutes, it's the same thing as that interval right there. That interval from 1.7 to 2.0, 2.0 to 1.8, and then kind of wrapping this up right here. Okay, so in the interval from 0 to 5, the velocity went from 1 to 1.2. We want the left endpoint, so we're going to go with the lower amount. We're going to go with 1. So it's going to be 1 plus, and the next interval from 1.2 to 1.7, we want the lower one, the left one. We're going to call that 1.2. And then 1.7, and then 2.0, and then I'm going to add eventually these up. And as I'm wrapping this up, in this interval from, let's say, 1.5 to 1.2, we're obviously going to add 1.2. And the left endpoint, I'm sorry, let me go 1.5 right there, so I can show you how the last one works. So from 1.5 to 1.2, we're going to go with 1.5. And then with 1.2 to 0, we're only going to include the 1.2. And then all of that right there would normally be multiplied then by the length of the base, which is 5. Now we got to think about units though here for a second, because we're going to be multiplying all of this not by 5, because this is in terms of minutes, but everything in our velocity is in terms by seconds. So we're going to multiply it by 5 minutes and 60 seconds per minute, so it's almost by multiplying by 300. So if I go through and actually multiply the lower end of all of those, starting at 1 and ending up at 1.2, and then multiply that by 300, we'll get a distance of 5,220 meters. Okay, well if I kind of do the exact same kind of concept, where here are my intervals, but this time I want to go with the right endpoints or the upper, then what I'm going to do is in each pairing, I'm going to choose the upper part. So the interval from 0 to 5 minutes, or velocity from 1 to 1.2, I'm actually going to start at 1.2. And the next one from 1.2 to 1.7, I'm going to choose 1.7. 1.7 to 2, I'm going to choose the 2.0. And as you can kind of get the idea going through there, the 1.8 to 1.5, I would go with 1.5. The 1.5 to 1.2, I'm going to go with 1.2. And the 1.2 to 0, I'm going to go with 0. Let's multiply all of that then times 300. Our 5-minute intervals termed in terms of seconds, and that's going to give us then a distance of 4,920 meters. And that's how it kind of looks like when you're using a table of values as opposed to analyzing an equation. So let's go on to example 4, which is number 14 in the book. Okay, so looking at number 14 in the book, an object is shot straight up from sea level with initial velocity of 400 feet per second. Assuming that the gravity is only the force acting on the object. It's going to be acting on it at 32 feet per second squared. We want to give an upper estimate for velocity after 5 seconds have elapsed. Okay, so what I'm going to do is create a table of values first real quick, basically with our x value being the time interval, so like 0 to 1, 1 to 2, 2 to 3, 3 to 4, so on. And then I'm going to list off on the y, on the next column, basically all the velocity. So let me do that real quick and we'll come right back. Okay, so let me just show you again what I did. Is basically on the x column, I just wrote out the different seconds. And on the right column, I wrote out the velocity, the equal of that when you're firing this gun. Okay, so at 0 seconds, the velocity coming out is shooting right away out of the barrel at 400 feet per second. Okay, but now after 1 second, it's gone against the gravitational pull for that little bit. So now we're at 368 feet per second. And then again, so it's like every second, I'm losing 32 feet per second every single time. And so that's what I've done. I did 400 minus 32, then minus 32, then minus 32, and then I developed a table of values. Okay, and so now for part A of the problem, it wants to know, we want to use basically a, what does it say? An upper estimate to see the velocity after 5 seconds. Okay, well we can think of it between 0 and 1, that's being 1 second, 2, 3, 4, 5, 6, and so on. Okay, so after 5 seconds, so it's like between 0 and 1, between that interval, the upper limit would be 400, because obviously that's the larger value. Between 1 and 2, the upper limit would be 368. So if we go after 5 seconds, so we go the first interval past this number, which is going to be right here between 5 and 6, if we do the upper limit of it, it's going to be 240. So it's going to be firing, or it's upward, the velocity at that point is 240 feet per second. Okay, and now for part B, to do a lower limit on the height now is going to be a summation of the velocity. Because after 1 second, if it's flying 400 feet per second, then it's gone 400 feet, or it's gone 368 feet, or 272. So what we want to do is sum up all these velocities as the bullet, or I guess this projectile is climbing and climbing and climbing and climbing. Okay, so there's 1 interval, 2 intervals, 3, 4, 5, 6, and so on. Now the problem specifically asks us for a lower limit. So in this first interval, from 400 to 368, obviously the lower limit would be 368. And then the next one, it'd be 336, and then 304, and then 272, and then 240. So there's 1, 2, 3, 4, 5. 5 numbers to represent for the 5 seconds in each one. And then if we add all that up together, we'll get 1,520 feet. So that's how high the projectile is, using a lower limit through those 5 second intervals. Okay, let's go on to the next problem.